Okay, hey, hello. I'm talking about metric storage for capacity management of OpenShift clusters. We've heard something about capacity management. So the part is capacity management needs highly aggregated metrics for node capacity, quota, and resource usages. Probably you want to keep this over several months and years. Unfortunately, Prometheus has only one retention policy for all, so we have a conflict here in our Prometheus system. For once, we want to have detailed metrics for post-mortem analysis, which we only want to need days or up to a month. And on the other hand, we need these highly aggregated metrics for long term. So we heard also before, the one solution to this is to have long-term storage which is filled via the Prometheus remote write feature, and with this we can keep the capacity management metrics in another storage. And as long-term storage, we decided for Thanos, as it provides a remote write target and provides the PromQL interface for querying again. So we can essentially use the same dashboards directly on Prometheus and on the long-term storage. So next thing is a small architecture for this. So for Kubernetes or OpenShift clusters, we have the classical setup. Here have the Prometheus within the cluster setup, and for the OpenShift part, another component is added, OpenShift state metrics, which provides us additionally with OpenShift specific metric data here. And of course the node exporter there. So the remote side we put outside our clusters to be monitored, because we want to keep the capacity management data for several clusters in one place. So we looked for a central storage system. So this can be set up on a virtual machine or in another cluster you would like. So for Thanos solution, we need a couple of containers to run them. So the first is the Thanos receiver, which receives the metrics via remote write, and then stores it in a S3 compatible bucket. In our case, we used the Minio container to do this, and we need regularly running Thanos compactor to get the storage efficient. For querying, we wanted to use Grafana as a visualization backend. Therefore, we need a Thanos query, which provides the query interface, Prometheus PromQL query interface, and a Thanos store container to talk to the S3 bucket. So what's the result of this is this capacity management overview, where we keep an overview of the whole cluster for memory, CPU, and pods, which are the typical resources. And yeah, what we distinguished, what we see on the right-hand side here is that we distinguish between the application and infrastructure containers, so we can keep an eye on both of them. The tricky part for Kubernetes is the quotas. There are some different writing possibilities to define quotas and to have several quotas per namespace. So I needed some weird PromQL formulas. If you're interested in the details, you can come to me later on. Thank you very much.
Thank you, Ulrike.
My name is Carlos Arilla. I'm working for Sharding as tech marketing engineer, and I'm a father of 3 children. You have a good picture. You notice my white hair. Well, let's talk about monitoring. But in a different way, because we are talking now about security. Are monitoring and security so different? Well, sometimes the first indicator of a security risk is to an increase of resources usage. So if you receive a cryptojacking attack, you will notice because your resource usage will rise. So many times it's an entry point of knowledge. And knowledge is very important for security. Many times you imagine security people as hackers in a terminal, but most of the time security means knowing what you have, inventories, things like that, that will provide you information about what you have in order to get information about what vulnerabilities can you have. And in recent years, DevOps teams have been the champions of the monitoring. But now, they are starting to have responsibility in security too. Because when you are in containers, or container is immutable, in theory, so if you do it wrong at the beginning of the process, you cannot change that in a further process. So DevOps team will have security responsibility and the ability to have tools that can work in both aspects can be very helpful. Let's go with the examples. Very, very, very easy example. Load. If you have a load increase, you can probably have a security issue. Crypto mining, spam, whatever. So if you have an increase of resources, you can probably be in attack. So you should investigate that. Next level is that in Kubernetes, in example, pods that are running without limit are especially vulnerable to increase of those resources. So I will leave you the task to mix those two queries to create one that could give you information about the pods that are more vulnerable to load increase and if they have been using more resources. A second example, we saw recently a vulnerability in Go that affected Kubernetes and everybody cried and so on. So I found this in Twitter that, in fact, is very clever. All the exporters in Go are exposing information of the version. So maybe you can use your own Prometheus to gather information about the version and to know where is running the things that are vulnerable. You can extrapolate this to different languages or libraries, and you can instrument your own versions here to have that information at hand. Another example can be a change in the expiration date of a certificate. Maybe that can give you information about someone that is trying to put in the middle of your connections and try to make a man-in-the-middle attack. So unexpected changes can make you suspect of the attack. And the next level, you can check too with Black Box Exporter. They recently put a TLS version. So you can check that you are running a safe version of your TLS in your application. And another one, very important thing is that usually one of the problems of a security issue, an attack, is that it will cost you money. That's most of the concerns of the security teams. They can spawn new nodes in a Kubernetes cluster or new EC2 machines in AWS. So with this exporter, you can track the daily cost of your infrastructure in AWS. So you can see if the cost increase unexpectedly, you can be in attack. And the last one is like error rate. You can see that here the number of error rate arise, so you have been attacked. So conclusions, DevOps need to be empowered to have security responsibility, and you should have that in mind to instrument your code with security features. Thank you very much.
Thank you very much, Carlos.
Okay, so I work as a DevOps engineer at Cloud & Heat. My responsibilities are configuration management of Prometheus and operations of our data centers. in my talk, From Basement to Skyscraper, monitoring distributed micro-data centers, I will talk about our experience with Prometheus, what we do to set it up, and my company, what we do is we put servers in basements or in skyscrapers, and we call those then micro-data centers, and we have different data centers across Germany mostly, some also in other countries. So this is the heart of the technology that my company does. We have a plate here. What we can see to the right is a 55-degree hot water comes in, 60-degree hot water comes out. And what the blade does, so we capture 90% of the emitted heat of the blade from CPU, RAM, and mainboard, and we use this heat. We use the water to this water is being used in the buildings for heating up buildings and stuff. So of course, monitoring is very important for us. We need to collect info about pressure, temperature, flow of the water. We need to collect a lot of info about temperature of CPU, RAM, and their usage, and also monitor the high-level services that run on top of the hardware. We mostly run OpenStack. So we have a very heterogeneous infrastructure. We have a bunch of different data center types. We now, with the newest addition being containers, we also, we have a legacy data center. We also have a state-of-the-art data centers. Prometheus needs to be ready for all of those kind of types. We have a big variety of racks per data center. We have different OpenStack versions, and what's maybe also special from our case compared to yours is that we deploy on bare metal and on VMs with Chef. So what did we do to make our Prometheus work? We wrote an exporter. We wrote a bunch of exporters that gave us low-level data that we needed for monitoring pressure and temperature and so on. This is OPC-UA is, for example, another standard that is used in buildings. We use that to monitor pressure of the pipes, for example. And we have a Digi Energy exporter and heat controller, own exporters that also do similar things. Then we also have written a smart exporter, which is on GitHub. You can check it out if you want, and a NIC speed exporter. With a bunch of other exporters, we then put this into Chef. Our configuration management, this takes care of, we give Chef the roles for each node, and it takes care of the targets and creating the Prometheus configuration. And we basically then click the deploy button and hope that everything works. Yeah, so Prometheus was very convenient for us and is still very convenient for us to use. What's also very convenient is Grafana. And here is an example panel of what happens in our data centers from time to time. So here, this graph here is the flow of the water. And at this moment, suddenly the flow just stopped, and we can see a whole rack of nodes, the huge increase in CPU temperature, and the nodes just suddenly dropping out from time to time, for example. So Prometheus is still up and running for us for a long. We've used it since 2017. It collects roughly 1.5 million series per minute across all our data centers. We had rare issues with it. Mostly, we have a retention time of 3 years, so sometimes the disk space runs full. Yeah, and yes, we know that's a configuration issue on our side, and we are working on using Tanos. And now we also have this new project called Crocker. This is an orchestrator that uses Prometheus as a basis to collect metrics for own scheduling decisions in a Kubernetes environment. Yeah, so here are some more links if you want to check them out. Yeah, that's it.
Thank you very much.
All right, hi guys. What else can I do with Prometheus? How about try to monitor network? So I'm Artem, I'm at LinkedIn, and I'm a network engineer. And so we tried to spin up Prometheus to basically improve our monitoring for networking stack. This is the motivation, kind of like high-level motivation why we actually try it. But in short, for a network engineer, you want to be able to find the problem, like whatever problem could be related to either something oversubscribed, interface flaps, BGP flaps, in like super short time. And with Prometheus ecosystem, actually, it's pretty easy to do, like roughly easy. And also ability to create dashboards and capacity planning, all of that stuff. So this is like simplified, oversimplified view of our existing infrastructure, let's say. So it's RRD-based systems that ingest metrics. Then we also have syslog that basically, and all of this then comes into the centralized systems that make sense of both worlds, like syslog events versus metric-based events. With syslogs, there's a whole bunch of issues where, like, let's say you have something misconfigured or the pod not properly deployed, and let's say syslog never reaches the collector, so you have the whole problem there. With RRD-based system, it's very, like, I would say, outdated. It's not dynamic, and it's hard to use. So what we try to do instead, basically typical setup where you have Prometheus clusters with alert manager, with federation. So all of this worked pretty well until we started sending too much data to federation. We UM'd it a few times. Then we had to add M3DB cluster. And this way, engineers could hammer it with queries all day long. So this works pretty well, but actually the hardest part was to connect to existing systems. So when we planned all of this, we didn't budget, like, time-wise for how much time it would take to actually agree with everybody and having all these discussions to send, because we had to have two systems in parallel, and to actually send all the alerts to existing system took, I would say, the longest time. So it's our, like, I would say when you were trying to build a system, budget for this. So when you all teams in line. And some challenges with, like, let's say typical leaf spine topology is everything L3. So when one link goes down, you will have at least 4 events. You will have, like, each side of the link, it's like physical link flap, then each side will report BGP flap. So you have 4 events, and this is just one physical link. If one of the boxes in the middle goes down, you can imagine how many events that will produce. And so correlation becomes, like, key. And we kind of, like, try to attempt to do it in Prometheus, which actually Brian helped us with an idea, come up with LLDP name. So what we do, we basically run a cache of LLDP, because if the device goes down, you don't have any more LLDP metric in the system. So this cache, like, let's say it's in some kind of cron job that runs, I don't know, every day or every 10 days, depends on the system. And the LLDP name is the same on each side of the link. It's basically sorted name, device A interface, device B interface, and based on this label, you can actually make sense that these 2 events they came from the same link. And so in the, let's say you want to do some kind of, like, interface flaps, so you enrich the E-flash change with this LLDP name, and then the alert for each side, you can group them together in alert manager with, like, just simple group by, like in this case, let's say LLDP name. And for the, you can also use this LLDP name when one of the boxes goes down. You don't want to send any, like, interface flaps or BGP flaps if the device is physically down. So it's some samples we did. The same idea for BGP, like, you come up with BGP ID, which is the same on each side, and that way at least you reduce it to one alert instead of multiple ones. All right. And this is just some examples of, like, how easy it is for an engineer to, let's say, troubleshoot some pages from SREs, like, hey, what happened at this particular time? You can clearly see that it wasn't caused by a physical event, it was just spike in traffic. And it's, like, super easy to use and dynamic. Once you show the engineer what they can do, they cannot go back to the old system. All right.
Thank you very much, Artem.
Cool. So my name is Manuel. I work for a company that you might be familiar with. So I'm an account executive, which actually that means sales. So I'm kind of an intruder here, and I'll explain you why exactly I'm here and why we have a sales guy talking about numbers. Usually, this is something that we normally do for those folks that have been here for the last years. We have a tradition going through the numbers behind Grafana and Prometheus and what we see in terms of number of data sources in Grafana coming from Prometheus and number of installs of Grafana during the last few years. So this is something that normally Carl does. Carl is an engineer, one of the primary engineers in Grafana team. He was here a couple of years ago doing this talk, only that Carl last year was not here because he was on parental leave. Now, well, he's in parental leave again. You'd probably, exactly, has twins, so you probably, if you want to have kids, go in Sweden. He's probably watching, I know, because he's missing it. He's tweeting about it. He has this FOMO of missing PromCon this year. At the same time, he's doing some soap or soup with the kids. So Carl, say hi to Carl. Carl, hope you'll be back next year and not send the sales guy talking about numbers. Last year was David because Carl was on leave, but David decided to spend some time with his kids as well. So, talking about numbers, we say we look into the numbers that we see in terms of installs of Grafana and numbers of Prometheus data sources into Grafana. In 2016, the first PromCon, we had 36,000 installs of Grafana and 2,800 Prometheus data sources. The next year, we had 92,000 of installs of Grafana and 16,000 of Prometheus data sources. Quite an increase there. 2018, last year, 186, so doubling that. Congrats to someone who's doing a great job. And tripling the Prometheus instances. Now, the question is, what happens in 2019? Any guess? So who says, like, we had 186 Grafana installs. Who says we doubled? At least doubled. Who said more than, so double would be 360. Who'd say 400,000? Okay. 450? 455. So this is how many Grafana instances are somewhere in the world, thanks to you guys as well, and a bunch of other people back home. Let's move to Prometheus. How many data sources we see of Prometheus inside Grafana? So 54 going from 16. I'm not saying double, because probably we did more than double. But who said triple? 150. Did you share the numbers before? Damn. I'm not gonna ask Tom. I'm gonna ask you. So who said we get 200,000? Okay. All right. I actually forgot the numbers here. 250. Okay. Well, 244, 242 actually, quite close. So, round of applause for you guys. That was pretty much all for me. Hope Carl will be back in 2020 if David doesn't want to come back. And I'll get the previous slides up if you want to take a picture. And let's get the numbers next year. Thanks, and continue to do a great job here.
Okay, thank you. Thanks.
Thanks for having me. A lot of this talk, obviously, on Prometheus has been about metrics, but we've heard again and again that there's often a lot of value by looking across the different data types you have, metrics and logs. We don't hear as much on as we should, I think, of metadata. And so I want to talk together about actually taking these three disparate data sources and possibly thinking about them together. In fact, we start to see this. There's kind of, there's really kind of two philosophical ways you can do this, and I think they both have value, so many of you could find them both parts. One is obviously to do it at the visualization layer, where you could have a unified visualization platform that could then talk to different disparate data sources. What we believe, we build a database, and we actually see also a lot of value in bringing all of this different types of data into a centralized data store. And from that, you could put on top of this Grafana, you could allow your business analysts to maybe use things like Looker or Tableau. You could use your data scientists through Python. In fact, you could reach raw SQL. And so in some sense, that's what I'm going to talk about today a little bit, and show you a quick demo of doing this on top of Grafana, is using a database, and in fact, one we built, TimescaleDB, to provide a centralized store for all of your observability data. And what this allows you to do now is to unify these different data types to kind of reveal the whole picture of your system at a specific time. So this is a developer conference, so certainly I actually want to show you a little bit of this working in practice. And so this is an example of data coming out of Timescale Cloud. And we're actually showing in this one picture both kind of query latency over a few things in normal graph view metrics. This is actually collected through Prometheus, as well as the logs. I should add, in fact, both of these things are actually using something that Timescale has built too, the connector from Prometheus, the adapter to Postgres on which Timescale runs. We built, as well as actually the Grafana connector for Timescale and Postgres. We also contributed. But you can look at this. One of the interesting things is now you actually get this one view of these both logs, and it's actually pretty simple to do. You could, for example, wrong button. You could just look at your logs, and it's really as simple as basically, here, it's really just selecting what container. So in fact, if you go back, you'll see that in fact this is one of the containers. You could switch, your logs will change, your graphs will change, but it's all pulling from this actual same data store. Now the interesting thing is, let's say you actually want to go down on what is effectively a Prometheus label. We actually have a consistent set of Prometheus labels now across our metrics and logs, and then that's actually what I just showed you above in the container name. And so I might say, show me all my Prometheus labels. In fact, that latency spike I don't really like, so show me a bunch of your logs in this graph, except there's a lot of them. In fact, I don't want to actually try to pull the 100,000 log entries from this time period. Across the broad area internet from our data center back in US, so I actually pre-did that, and that's what my laptop might crash soon from Grafana. But that's what it looks like to try to visualize 300,000 annotations in this one time period. But the nice thing is we could actually dig a little deeper. And in fact, just using again the annotation, I built what is effectively just a little suspicious logs query. And all I'm saying is I just want the set of metrics that I want the logs corresponding to the metrics that are above 200,000. And this is not something you could really select if you just have labels. You're actually doing a query on the data, on the structured data itself. You do not want to express that in terms of cardinality. But once I have that super small set, I can in fact just look down. And that's what you're actually seeing on these log entries, just these suspicious metrics. And once a little debugging, you've actually discovered that this is due to a high availability failover between two running instances of Timescale. And the nice thing is I'm running out of time is that it's also about metadata. In fact, what I also did here is I don't store this directly in the Prometheus log, but we also actually have view of which are the users, which are the tenants mapping to that particular container. And again, this is all coming in the same data store, and now I could learn that these two users are affected on this container, this user is affected on in that container, and so forth. Now, how did I nail this? I'm quickly running out of time. It's because this is not, we think the value of this is not just long-term storage, it's actually building the power of true database. Timescale, in some sense, is built as a cloud-native time series database. We actually built on Postgres, but we've kind of changed its architecture really significantly to really optimize for time series data like metrics. We first launched in April 2017 and since had millions of downloads, and really since there have really expanded it to kind of petabyte scale. So you get full SQL with the entire Postgres ecosystem, but you could deal with huge cardinality, elastic scale, and native compression now, and data tiering. In fact, you can move things from hot storage to cold storage all in the cloud, and it's super simple. A lot of interesting future work, including we're looking at native PromQL interface.
Right, thank you very much, Mike.
Thank you.
Hello, so I am Geoffrey Beausire, and I am a SRE at Crito. And today I'm going to speak about how to manage 600 Prometheus instances. So first a bit about Crito, because to understand the scale. We do online advertisements, so the ads that you can see on websites. On the technical side, we have more than 40,000 servers across 10 data centers, so we do a lot of bare metal. We have 2 large Hadoop clusters, and we handle 6 million requests per second. that should be answered in less than 100 milliseconds. Whoops. So Observability at Crito, it's a dedicated team of 4 persons, and they are responsible for maintaining the Observability stack, so metrics, logs, and tracing. On metrics, we have Graphite and Prometheus, and more details on Prometheus, that we have 642 instances, I counted this morning. 3 million samples per second, and the most common resolution is 1 minute. And we have more than 300 committers on the configuration file monorepository. So how do we manage 600 instances of Prometheus? Well, we don't. Each team is responsible for their own instances. So basically what we do is we have this notion of parameters. One team has 1 or maybe more parameters. And basically it's a separation. A parameter describes the service of the owned by the team. And it's a general global local topology. So 1 Prometheus in every data center or less if it's needed, and federated by global Prometheuses. And everything is running in Mesos. So why do we do that? So it's a low maintenance cost for the Observability team. It provides an isolation between teams because you don't want somebody that messed up with rules or targets to impact the alerting another team. The freedom of usage, so all the users can use all the capabilities of Prometheus, and often they do. And there is a clean ownership separation, so that Observability will never answer for an alert from another team, and it's valid for all the teams. And the disadvantages, so obviously it's added workload on the client teams, and there is a high entry cost because you have to learn how Prometheus works and how to use it inside Crito. So how to make it easier for the teams to use Prometheus? So you can reduce the workload by providing shared services. So we provide 1 alert manager. You can ask for 1 dedicated for you if you have special needs. And we use generic routes that will route the alerts depending on the labels given by Prometheus. So basically, we almost never touch the alert manager configuration. We have common exporters like the black box exporter that are shared, that everybody can use. If you need a special exporter or if you need special configuration, you can build your own, and it's very easy because everything is ready for it. And we have the Graphite remote adapter that receive metrics from Prometheus and passes them inside Graphite. We can also reduce the workload by using efficient tooling. So we have a reliable meta monitoring. So it's basically a parameter dedicated to watch the other parameters. And users can choose how they want to be alerted. And all the alerts are actionable and well documented, so the users know what to do if they receive something. Tooling is available to debug more complex issues, like out-of-order issues that can be tricky for users to find out. And we have Grafana dashboard for Prometheus stats. We also reduce the workload by acting as a consulting, so we don't let the users alone. We give users advice on how to best monitor the application. We dig deeper if they're into complicated issue, basically everything that is not trivial to fix. We take care of upgrades, and we provide workshops to onboard the new user to explain how it works. We also use a lot of automation self-service, basically creating a new parameter. So the Mesos configuration, the pipelining for CI, and the Prometheus placeholder. It's done by one simple job in Jenkins. Prometheus is simple to test locally. Basically, we have Windows, Mac, and Linux, so we can do it very easily. And configuration is tested when creating a review. So we check the rules, we check the documentation. So on alert, it's enforced, and we have select channel and objects that are validated that they indeed exist. So to finish, start small. It took years to build it. Automate progressively. Listen to users' feedback to know what to imitate first in the PowerPoint.
Thank you very much,
Thank
Geoffrey.
Hello, I'm Frederic. I work at a small company called GitHub that some of you might know. But that's not about my work at GitHub. It's more about my work at the CCC NOC. If you don't know what the CCC is, the CCC is a non-profit organization mostly by hackers and nerds and IT professionals. It's a completely non-profit run organization and event. The event usually runs for 4 to 6 days, depending on the event. The Congress is usually between Christmas and New Year's Eve. With usually, I mean always. The camp is every 4 years, but some other camps are like between the year, or like every other year. Those are run by Dutch colleagues and British colleagues and so forth. But the cross collaboration is very large, so we attend those events usually as well. The Congress is like 17,000 people, so you can imagine like this room, a lot bigger. And we're now at the CCL, that's the Leipziger Messe, which is a pretty big venue, and we used to be in Hamburg, now we're in Leipzig. The pre-sale started today and went out, or was it today, was it yesterday, I don't know, today I believe, and it went out in 17 minutes. That was the first stage. Of the pre-sale, there will be another stage later. The camp is about 5,000 people that attend. And we run the NOC, or I run the NOC together with others, and we're about, I believe, like 20, 40 people that take the time to do it. And usually that's like at least a month or 2 or 3 in advance, sometimes even half a year to a year in advance of organization. And with that comes permanent infrastructure, but also temporary infrastructure, as I said, is running for 4 to 6 days. Means Prometheus retention is 2 weeks. Isn't that a beautiful thing, right? No long-term storage. Because at the end of the event, we delete everything. We keep nothing because we like privacy. We don't know what we're storing, what could be related to a user, so we delete everything. We have about more than 400 switches and access points. Access points probably like 200 or something. Many routers, lots of sponsors, multiple hundreds of gigabits per second capacity. Last year at Congress we had 500 gigabit capacity, all sponsored. We didn't pay for anything, which was pretty awesome. This is what it looks like in hardware. Lots of switches, lots of spaghetti cables everywhere, and it's all temporary, so we set it up like a week in advance and run with it. Okay. So infrastructure layout for Prometheus. So all that infrastructure also needs to be somewhat monitored. We need to be looking at utilized links and all that. And we have a public Grafana that is fronted by an Nginx to terminate SSL, fronted by a Varnish because 17,000 people or more on the internet will access that dashboard and look at statistics. And we don't want them to wade through every graph that we have on this dashboard. So we shield it off by some rewrite rules and all that. But we have an internal version of that as well that directly communicates with the Prometheus server where we can do dashboards. We have lots of exporters. We do lots of SNMP, hopefully soon more telemetry. We use the node exporter very extensively to the extent that we have 17 servers, not a lot. We use the Junos exporter, Blackbox exporter, but the more important piece is people write their own exporters. So we have the VOC providing us, I believe some of them are here, provide us with information for the public dashboard, the Angel system, usually well in advance. We have power utilization, water pressure at camps, so you know when you have to take a shower, so no one is there and all that. And DHCP fuel usage, which is great for capacity planning for the next year. Yeah. Service discovery, we operate by the principle of netbox and chill. Means we put everything in netbox. It's a system that looks broadly like this. Lots of links, computers, switches. Okay, and yeah, what's in there is in Prometheus. Dashboards and graphs. This is part of the public dashboard. I always forget to take a screenshot at the end of the event. If you can remember for me, please do so and send me the link. That's radio capacity. That was a little bit of a cliff there for 10 gigabits of radio capacity that we had on the camp, meaning a radio link that goes to the next village giving 10 gigabits of capacity. Yeah. Just like 2 seconds. That's like our availability dashboard, which we use for build up and and during the event for all the switches and access points, and yeah, some other dashboards that people build. More importantly, people use it for Morse codes on the public dashboard. So
Thank you very much.
Hi everyone, as said, I'm Christian Simon, and I'm speaking about a slightly smaller event. So we have around 2,000 visitors, and it's something I'm doing in my hometown, maybe an hour away from here, for the last 15 years, I guess, with a couple of friends. And at some point, I switched from Zabbix to Prometheus, I think 3 years ago. And basically the main purpose I'd like to look at is because I'm responsible for the power supply for all the stages and all catering and stuff. So basically I want to know when RCD fails, because there are all sorts of reasons. We have quite a lot of connections outside, and like, yeah, some of the catering places, they are not really done well from an electrical standpoint, I would say. And so like, there are all sorts of problems throughout the evening, and you really, you struggle to just get phone signal if there are that many people sometimes, and so it's really hard to get anything. And so basically, my approach to this was OpenWRT and cheap access points that I just WireGuard into the cloud, and then, yeah, export some metrics that. Yeah, I'm not really using them much. I think I'm using a bit of port status of the switches and things like that. But yeah, I'm using the OpenWRT Lua node exporter that someone wrote. I just packaged it at some point, I think, for OpenWRT. And yeah, so that's the main use case. And basically, the main thing I care about is if something is down or not. And a nice thing I just wanted to show, so it was just 2 weeks ago, the festival, and I discovered that Grafana diagram plugin. And you can use Mermaid, which is like a GS graphing library, and you can color it based on Prometheus metrics. So I found that quite interesting and was set up in no time. So basically, like, yeah, that's the rough logical layout. And yeah, the numbers here, for example, would show how much uptime they had over the festival. The Mermaid itself looks a bit like that. So that basically draws the logical graph, and you then replace the colors with some more bespoke Grafana config that I think doesn't fit the screen really well. So I think, yeah, that's the main thing I wanted to show. I really like that plugin. I'm probably going to use it a bit more in my real life, where I'm also looking at Prometheus. And yeah, so basically I also have a couple more ideas, because if everything goes well, I have quite a lot of time throughout the festival. So basically, maybe measure the actual consumptions so we have 2 connection points to the grid, maybe measure the consumption there. We always talked about like some kind of OpenCV monitoring how many people are on site, because there are strict limits from the authorities. So we actually recorded some video stream that we need to figure out if we can count that with OpenCV at some point. And yeah, right now, all the kind of Prometheus stuff is pretty much Ansible static, and I'd like to do that in a bit more dynamic way, and yeah, use the file discovery. Cool, yeah, that's everything I wanted to talk about. So.
Thank you very much, Christian.
Hello again. PromQL aggregation sharding. So we've heard from Chris why high cardinality queries are bad, and I'm going to tell you a different way of potentially maybe fixing that. So I'm going to, for the sake of this 5-minute lightning talk, I'm going to argue that all PromQL queries look like this. I know that's not true, but like probably 80%, maybe 70% look like this. And the reasoning behind it is, if you're querying millions of time series, you're not displaying them, right? There's too many time series to fit on even on a high definition display. So you're doing some kind of aggregation to reduce the cardinality of the output set, right? So that's why they all look like this. Now, one of the nice things you can do with this query is you can turn it into this query. And I've quoted the plus because it's some kind of merge operation. And obviously, you can't actually shard stuff like this unless you've sharded your time series, but imagine you could. Imagine you could do this, and then you could execute each one of those, can't use the term subquery, have to use a different term, but each of those subqueries, partial queries, thank you. in parallel, independently. Imagine if you could do this, right? Imagine if there was a way of guaranteeing that time series would be equally distributed amongst these shards and it was all automatic. Well, we can. Well, we can almost. Like these results came out of a dev system from Owen, and he gave me them last night. It's really super early days, but this is what we're working on at the moment. This is, again, it's a dev system. It's running over only a few thousand time series, so this is artificially slow. We're kind of working on it, but this is the query we did. We did a container CPU seconds total, which everyone will know is a pretty high cardinality metric if you use Kubernetes. And this is before. It took 10 seconds, and after the sharding, it takes 2.9 seconds, which is an improvement, right? We're sharding it into 16 shards. It's not 16 times faster, which we want to understand why. But these results are super early, and this is the same query or slightly different query, just for an example, so it's repeatable at least. This is a trace. As Gotham already showed this morning, we have Jaeger tracing for everything. So you can see the queries being executed in parallel. And yeah, I mean, that's pretty much all I wanted to show you. I don't know why I have another slide there. It's just going in a loop now. Yes, so, yes, thank you. So right now we're developing this in Cortex in the query front end. There's nothing here that's Cortex specific. So we'll make this work for Thanos, we'll make this work for M3, we'll make this work for just plain old Prometheus installs. And actually in a Thanos environment, it makes even more sense because you can push the individual, what do we call them, partial queries, down into each of the edge locations, into each of the edge Promethei that are running in your Thanos cluster. So I think that's going to be pretty cool. One of the other interesting things here, the results are slightly different. Now we've checked, we don't think it's a bug. We think it's just the order in which you add floating point numbers matters. So they're only ever so slightly different. But yeah, that's kind of all I wanted to show you. I didn't do this work, by the way. The only reason I'm up here talking about it is because Owen, who's been doing the work, couldn't make it to PromCon. And Cyril's been helping him, so I wanted to give a big shout out to these two who've been doing the work. Thank you very much.
Hi, so I would like to tell you what it's like to get people who don't care as much about infrastructure as we do to use Prometheus. When I went to PromCon in 2017, I was super excited to be solving a whole bunch of cardinality explosions when I got home. Well, it turns out that if no one's using your service, you don't get to solve these fun problems. So this is me. I like computers. I like weightlifting. I also like being a captain of a starship, but I don't have a ship and I don't have a crew. Here are all the titles that I've had and the places that I've worked. So in my previous job, this was what I was asked to do, to have a combined Prometheus set of deployments for a whole bunch of companies that were being put together. A whole bunch of varied developers in different languages and different services. They had a bunch of pre-existing monitoring tools. A lot of them were in the about to die. Lots of microservices, a ton, and a whole ton of nodes. So it's my job and my team's job. Go monitor it, all of it, 6 months, go. You can't do that? Okay. I need to help each team do this for themselves. So how do I separate this and then make this accessible? So my solution, we did end up hosting Prometheus as an infrastructure team. But what we did is we made a walled garden. We made the barrier to entry as low as possible. And we exposed alerting, recording rules, ability to add exporters and good testing environments. And all you had to do was commit and push to put rules out on the system. So that was the first experience that people would have is implementing alerting and recording rules, so they had instant feedback. So that left scaling and tuning and Prometheus performance problems to me. And yes, we did have them, but at least we had customers, so that was great. Communicating was super important. for onboarding. It was a lot of application, talking about applications and exporters and how to write alerts and rules. What did I do wrong? What woke me up at night? So I got really ambitious about parallelization my deploys. I had branch deploys, I had all sorts of things, and I was too too shy to merge to master when I should have. I should have put that in the automated deployment flow that I had. So I ended up having to resolve drift problems early on, and that was a huge pain. The other thing was I didn't put initially in my workflow was silences. So it's either me waking up or them waking up, and because I want them to use my service, it was me waking up. And I also, I don't know why I didn't do this, but I didn't initially expose or educate people about PromTool and AmTool. So I end up having to solve those sorts of problems which they could easily do on their own. So what you should do from learning from what I did is get people to who know their applications to do their own instrumentation, give them a workflow, get out of the business of writing alerts and rules yourself. And I'm about to do this again at my new company, so I'd love to hear about your experiences, and we can all learn together and do this better. Thank you.
Hello, my name is Alexander. It's actually my first PromCon, so I'm glad to be here. I want to talk about Victoria Metrics cluster. Actually, I love complex things, but as operations, I love to work with simple things. And I think Victoria Metrics is a pretty simple thing for a cluster. Actually, here, a diagram from the GitHub repo. You can look at this diagram there. There are only 3 things which we'll be talking about. It's VM select, VM insert, and VM storage. So other just how you connect some other thing to VM cluster. Yeah, it's pretty simple talk. So actually you have VM insert. It's where you write your metrics from Prometheus. You can use just some remote write. You need to configure only remote write, and VM insert as binary will split evenly between all VM storages which you have. So it's pretty simple. VM select is where you point your Grafana as data source. So if you want to show this metrics in your Grafana dashboards, you just point to this VM select. VM storage is where magic happens. So it's a testDB written for storing data. So you can use VM storage as a solution for long-term metrics for your Prometheus. They're using compression. And it's really good. If you saw a talk from yesterday from Adidas, compression is pretty good. Yeah, scaling cluster. Actually, scaling cluster is quite easy, and that's why I like it. Because if you want to have more VM inserts or more VM selects, you just create one of them and point it to existing VM storages, and it just works. So they are stateless. VM storages, you can scale them up easily. You just add a new one, and you have new metrics there. But it's simple, and it's good and it's bad. So no resharding, nothing like automatic migration of data. New data just happens there, and that's all. It's cool, but if you need some complex thing, it doesn't this. So, but if you need to scale down, it's hard part, and actually, I don't know how to do it well. You just need to maybe turn it off from VM insert and you can remove this storage from VM insert and wait till retention period removes all the data, and then remove your VM storage. So it can take can take time. Okay, load balancing. You need some for high reliability. You need some balancer before you VM select, VM insert. So if you use Kubernetes and they have Helm charts, and you can just use ingress for this. But if you don't have Kubernetes, maybe you need to use Jinx on something like this. So VM insert balances between storages just on hash of metrics. So if you have a new storage, some metrics will go there. Like I said, in my test setup, my test cluster, there is a difference between new storage nodes and old storage nodes, and it depends when you add them. So in terms of nodes, you don't have a replication there. So if you lost one node, you lost metrics from this node. So you need to make backups. But you still get other metrics, so your cluster will be operable, but without your metrics. Okay, as I said, configuring VM cluster for your long-term storage is easy. You just need to add remote write into your Prometheus configuration, configure data source, and pretty much it set up VM cluster. It's really easy. Yeah, that's all. Thank you.
So obviously from yesterday's talk from Alejandro from Adidas, we're talking about Victoria metrics, and like those right numbers were pretty impressive. But we're also asking questions about, okay, it's a question from over there, what about reads and so on. So I figured, let's look at things and figure it out. So I did some looking last night after I got home from the event, and I've actually been running some stuff as well. Oh, good. Oh, God. So I've, since this morning, been running Prometheus here, which is just scraping itself, and my expose many metrics script, which is, like, everyone writes a script to expose some metrics or benchmarking. By the looks of it, I was last looking at table sizes with it, but I've got it putting out 10,000 metrics. And basically, every time you scrape it, it increments by a random number between 0 and 1. So that's there, and it's also got scraping Prometheus. So I've got a Victoria metrics here that's been running since, well, the same time. So should all be the same data. So we can go over to snapshots. So I can take a snapshot for both, because we want to compare like with like, and like comparing the WAL from Prometheus isn't quite the data sizes, because it's not the long-term stuff, and apples to apples comparisons are tricky. So I think this is apples to apples. So I will now ask both systems to snapshot. One of these takes longer than the other. And we can now look at how big these are. Guess I made it a bit too big. 28. There we go. So here we can see that Prometheus, the one I just did, is a bit over a gig, and Victoria metrics is 1.1 gigs. So it looks like these are basically the same. In fact, as it started out this morning, Prometheus was a bit bigger. Now Victoria metrics seems to have trended to be a bit larger. So it looks like things are about the same in terms of size, because it's the same data that Prometheus is sending out via remote write. So in principle, at least, I expect Thanos to be comparable, and probably also Cortex, because it's also using Prometheus chunks. I know that M3 is using something different, so it might well be using more. So it looks as though, because this variation of Victoria metrics is the version that was released 3 days ago now, version 128.3, and Prometheus is the latest stable release of 2.13.1. So it looks as though things have changed since whenever those benchmarks were last done. But I have another 2 minutes, so I'm going to look at some other stuff. So the question was asked, can we get the same data back out? Where have we gone? So we'll do process CPU seconds total, and this is going against Victoria metrics, whole pile of data. What we always love to see. Process CPU seconds total over the last 5 minutes. So there we have some numbers. all these timestamps are conveniently, it's every second, ending in 0.441. Oh, this is the wrong order, because it's got both the, no, we can do it this way. Oh, no, we can do it that way. So it's the 536, so it'll be up here. So this is the Prometheus. So 27809, where is that? Oh, that's not here. Let's see, 157.322 to 738. These are, what is it? 738. Okay, there it is. So 42601.05, 42601.05. That looks good. Although it's odd that the latest data that Victoria Metrics has is a bit back down the page. And we might consider something else. So let's say go memstats GCCPU for action in the 30 seconds I have left. Execute that. They're both Go binaries. Live demos, eh? God, 10 seconds left. Sorry, I have a minute left. Oh. Okay, so here we see, we can just go 157, grab that fella. And our value here then is 66802, and this is 866, and it doesn't seem like it has the full number. And previously, they are slightly different. It also appears, I'm not going to show it because time, that Victoria Metrics is dropping nans, which means it's not even storing all the same data. That also means staleness isn't working. I have checked that, but I'm out of time. Thank you.
Hello. Yeah, so I'm Rob. I'm going to talk to you about why you shouldn't use a long-term storage for the first part of this talk. So I wanted to talk a little bit about pain points running M3 and how the replication works. So why would you want to try to run anything clustered? Most people don't, and in my opinion, rightly so. I think that most setups do perfectly well with a small number of Prometheuses, and medium and larger number of Prometheus works just as well if you have the infrastructure to support that at your organization. And then, you know, I think to dig a little bit more into why would you not run anything clustered for your monitoring, running distributed systems typically takes a lot of work. Learning concrete types of distributed systems, distributed stateful systems like Cassandra or whatever. There's tons of other stateful distributed systems out there too, like Kafka and such. It sometimes involves like several magnitudes higher amount of time to learn than a programming language, which, you know, I think like perhaps maybe it's easier these days to pick up new languages because they look very similar, or maybe not. But that's a long amount of time and a large investment. So all right, so coming back to why would you try to run anything clustered? So typically the use cases I've seen is like a single application that wants to be viewed from a single instance, has to be collected by more than one single, like basically needs more than one single monitoring node to basically store all that data. You can do a few things. You can not try to store that many metrics for a single application. That's usually the correct thing to do. So unfortunately, there are some use cases though where that is very difficult, and I've seen people running, you know, 500 gigabyte heaps or 1 terabyte heaps with Prometheus, which is interesting. It works though, so you know, I think like that's also a perfectly valid thing to do as well, scaling up vertically. So the other thing you might, if you might want to do this, is if you depend really heavily on the metrics themselves. So, you know, if you have some kind of rudimentary anomaly detection, or perhaps you have automated load balancing, or you have some other things where basically any amount of downtime is quite bad and will make your load balancing of certain clusters or routing of certain network edges fail because they rely on the metrics to actually perform those routing tasks, then you really want high reliability. Because you're basically not using metrics as monitoring. You're in some ways, you're using it as a platform. It's almost like how databases would use databases are used to serve applications. Is a core part of the application you're building is stuff. And so ideally you have replication on that, ideally RF3. And yes, you might want to be able to lose an ephemeral instance if you're not running in the cloud. So or if you're in the cloud and using local SSD instances in the cloud. So a quick background for how M3 works before I get into the pain points is that we store everything in Quorum across 3 replicas immediately. So we don't use cloud disks. This runs on-prem if you wanted to, and it basically means that immediately as soon as you write a copy, it's across 3 availability zones or like 3 racks if that's what you're doing for isolation. So let's quickly go to categories of pain. So bootstrapping times with large instances with M3 I think is a big thing. I mean obviously large Prometheus instances there's obviously been a lot of work that Ganesh covered is happening, but it's like typically a thing with a lot of these storage systems, memory and downsampling. And so on the bootstrapping times, really large heap sizes can take a really severely long amount of time. This is okay sometimes in the M3 world, since if you lose one node, then other replicas are still up for Quorum reads and writes. If you lose more than 2 or more replicas at a time, it's still okay because we actually accept writes while you're bootstrapping. And now we're actually moving to deferred and asynchronous merging of data points, and that gives us about roughly like turns a 30-minute bootstrap into 2 minutes. So how much memory am I using? We use a lot of mmapps, and these aren't actually evicted from the page cache until you experience memory pressure. So essentially now we use madvise to tell the operating system that actually we don't need these pages anymore, because what we do is we basically do a checksum across the entire page, which is all into the page cache immediately. So basically, our memory RSS size is like very heavily bloated. So, but now we're going to try and call don't need from madvise to basically make sure that that doesn't happen. Well, it's not misrepresenting page caches that are not needed anymore. And yeah, put it off there. Thanks.
Thank you very much, Rob.
Hello, better. Hi, I'm Łukasz Mierzba, and I'm gonna tell you about a tiny little tool I wrote recently that allows you to acknowledge alerts with Alert Manager. So in Alert Manager, any alert can have 3 states: unprocessed, active, and suppressed. And the unprocessed is the initial state before Alert Manager has an ability to check any alert against any silences that you might have defined. And once it's checked that, it puts the alert in the active or suppressed state. Also, inhibition rules could put any alert in suppressed state. A lot of other monitoring systems have also the acknowledged state, where you can click an alert that you received and marked it as something that you're working on, like nudges. Unfortunately, in Alert Manager, that's not possible because effectively you have only those 2 states, active or suppressed. And there's a reason for that, which you can find in docs. Typically, the advice is to use systems like PagerDuty or OpsGenie to push your alerts to those systems and then manage all the pages inside those systems, which is good advice, but not everyone uses those external systems, or sometimes you don't want to push those alerts to those. And I did want to have an acknowledgement system with just Alert Manager without any external services. And the usual advice for that was to just use a silence, which is a fair advice, but the problem is that silences are something that you need to add manually, and then you need to ensure that they are removed when the silence is no longer needed. So to manage alerts and have some way of auto-expiring silence once the alert is gone so that you don't need to manually remove that, I consider 2 options. The first one was to create a silence with a very long duration, and then once the silence doesn't match any alerts, expire that silence. And this option seemed a little bit more tricky to implement, because if you have a very long running silence, then you need to keep some tiny little state to know when the silence doesn't match any alerts. And the other option was to create a silence with a very short duration and then keep extending it as long as you find alerts firing for it. And for that, I implemented tiny tool, which took me like just one afternoon. to write, which you can find on GitHub. And it does exactly that. You create silence with Alert Manager, and then this tool will keep extending those silences as long as there are alerts firing for those silences. And this is an example of the output. You can see, as you can see, there's one silence that would expire soon, but it's still matching some alerts, so it's gonna be extended. And there's another silence. This one doesn't have any alerts for it, so the tool will let it expire. I also wrote a different tool, which is Karma, which is Alert Dashboard, so I wanted to make it even easier for myself, so I added the ability to just silence alerts with one click, which you can see here, hopefully. As you can see, you can just click on one button. It will create a silence for you. And then if you have that tiny tool I just mentioned running along with your alert manager, then it will keep that silence running as long as the alert is firing. Once the alert is gone, the silence will be gone. And this way, you don't need to worry about managing silences yourself. That I did. Oops, sorry. Well, the takeaways. Not everything needs to be a core Prometheus feature. So it's very easy to extend Alert Manager and Prometheus by using their APIs. It's especially easy to write Alert Manager API clients. I didn't need to learn any docs about API for Alert Manager because I use the Go client libraries that are included in Alert Manager itself. And it was really easy task to do. So I encourage everyone to just take a look at the Alert Manager code and use it.
First things first, I have a really bad memory for names, and the Secondos guy was Heinrich Hartmann, very catchy name. And he live tweeted my whole talk, and I gave him, as my thank you, that I forgot his name. My sincerest apologies, Heinrich, if you're still listening or watching. It was my fault. We talked for ages at Recon, so I should really remember, but yeah. Anyway, Brian encouraged us to give like spontaneous lightning talks, so I took my Prometheus branded notebook and made up a lightning talk. I mean, I wanted to give this talk at some point in the future. Now I just wing it. Cacheability of PromQL queries. We know there's Trickster. There is the Cortex query frontend. Okay, Tom nods. Your name is Tom, isn't it, right? Okay, so and I was always thinking about, can we actually cache PromQL queries? I mean, obviously the newest data, like if you have this dashboard that reloads every 5 seconds and the whole company is looking at it because we just have an outage and they bring down Prometheus, hopefully not, but we want to cache that, right? That is the idea. And of course, the newest and hottest data cannot be cached, but we can kind of manipulate the query and just like do a query range for the like data we already queried before or something, right? We can certainly do that. Like, who thinks that would be an effective caching strategy? Tom thinks that. So what's going wrong? The problem is that, at least in the olden days, whenever you reload a dashboard, it would like ask for the newest data and then like every 10 seconds for the later data. And since you do this at some random point in time, you will almost never hit the same timestamp. For Prometheus, this looks like a completely different query, and your like dumb cache would just see this is a different query, so why should I even cache that, right? So what you can do, you can align the timestamps, and that's what the Cortex query frontend is doing, that's what Trickster doing, and incidentally, Grafana is doing this by now too, just because they don't want noisy graphs to jump around too much. But very convenient, so now all the timestamps are aligned, the data should be perfectly cacheable. True or false? Who thinks that's true? We can just cache all the queries. Nobody, why not? Okay, I mean, there are too many things. I should first do the easy part. So there's one thing that's, I mean, most of this stuff you can know from the talks we had here. We talked about this ingestion isolation, which already tells you that samples show up like one after another. So it can totally be that a sample didn't make it into the storage, so you are caching an incomplete query. When you run it the next time, it might look different. So that's already a bit dangerous. That was really dangerous with Prometheus 1 because it could have like 5-minute indexing delays, and you would only see those queries later. So you should not cache super fresh data. So let's say we just cache data that is at least 1 minute old. Is that okay? True or false? False? Okay, should I ask why? I should ask why. Who said that? False. Okay, he should know. Yeah, so you can ingest all the data. So I mean, that should never happen because Prometheus dictates the timestamp unless you are crazy enough to put timestamps into your exposition format, which you should never do, but you could do, right? So what time span do we tolerate? How old can it be? No? He says 2 hours, 3 hours. I think it's 1 hour. I think we do 2 hour block. It's 3 hours? No, I think it's. But I think we reject timestamps that are older than 1 hour. Yeah. So, I mean, the thing is, the write-ahead log that we also talked about can be 2 hours old, and then it's condensed into a real immutable block. And then we keep doing this for another hour. So you always have 1 hour headroom, essentially. And I think even if we have 3 hours at that time, we always reject anything older than 1 hour. That's my knowledge. Okay. So if we only cache query data for queries that are like for data that is older than 1 hour, are we finally done? I have only 1 minute, so we should be done. No, we are not done. So that was mentioned by Ganesh. Why are we not done? Backfilling. Prometheus is now so awesome it can backfill. So totally somebody could come along and backfill data, and then your cache queries are all invalid. Okay, so if we do backfill, if we allow that on our Prometheus server, we need to invalidate the cache. And I think the query frontend isn't doing this, and Trickster isn't doing this because it's a new feature. Okay, final thing. There's one final reason why this caching is still not perfect. I mean, perhaps there are more, but I couldn't come up with one. What is it? Deletion. Yeah, I mean, he knows that, of course. So we have a retention period, and Prometheus would just never respond to, like, it would never return data after the retention period. But your cache can't know about that, right? So if you want to be super truthful, you have to take this into account as well. And I think that's all you have to take into account when you cache PromQL queries. Thank you.
Hello, my name's Brian Borum. I work at Weaveworks. I am a Cortex maintainer, and I remove buckets from Kubernetes, so you can thank me for that. I decided to talk at the very last minute about a project I've never worked on, but I think it's really cool. So you know, why do we do this, right? Why do we do all this work? Basically because we get to play with the toys. And this particular project will let you play with pretty much all of them, service meshes and Kubernetes and Prometheus and everything, oh my. Who, by the way, the tool is called Flagger. Who's heard of Flagger before? Yeah, just a smattering. Okay, so it's cool. I'll tell the rest of you. You guys can relax, just chill out, you know about it. You can read about it at docs.flagger.app, or it's on GitHub. It is written by my colleague Stefan, who is really cool but couldn't be here today. And so what does it actually do? Well, first of all, what's a canary deployment? The basic idea is that you have a new version of your software and you're going to roll it out, but you don't want to roll it out to everyone all at once, all of your end users. So the idea of a canary is, you know, you take it down a coal mine, and if it falls off its perch, then the oxygen's bad. So that's what we're going to do. I have this little diagram here. We're going to walk through the stages. So we start off. We got version 1 running, and version 1 is receiving all of the traffic, and the traffic is coming in through a service mesh, something that can redirect the traffic. So we need something like a linker-D or an Istio or something like that in your, see what I mean? You get all the toys. We come along with our version 2 of the software, and Flagger automatically tells the service mesh to send, you know, like 5% of the traffic to the new version. And then the even cooler part is it watches metrics in Prometheus. So, you know, this metric can be like error rate or latency or something like that, or you can just write your own PromQL query. So it rolls it out, it waits a few seconds, and it watches the metric. And if it's all good, you know, like we're still getting 200s or whatever, latency's still good, all good, we start to ramp up the percentage of the traffic that is going to the new version of the software. So we come up 5%, 10%, 20%, ramp it up slowly. Flagger is doing all of this automatically, talking to the Kubernetes API. We get to a certain point. We're still watching the metric. If the metric goes bad, latency goes way up, it rolls it back. We go back to version 1 automatically, and then you get to debug it. If not, we carry on. We set the traffic going to version 1 to 0. So we basically undeployed version 1, and now we're completely on version 2. And we take away the kind of temporary ones that we put in there for canary purposes. So that's it. That's Flagger. It's really cool.
Thank you very much, Brian.